All right. So hello, everyone. Once again, we will sort of continue from the last week what we talked about in terms of uh, building resilient system. And I think I want to highlight one thing because when I talked about yesterday, I think it might have been a bit confusing as to, hey, how does throwing exception is going to lead to building resilient systems, right? Because what I basically proposed is, hey, your job is to throw exceptions, and uh, uh, that should be your main goal. And I want to sort of expand that on a little bit, and I will use that this analogy of that Chotu making the tea as to, hey, how is that going to pan out, right? Because if you think about it, if that person did not use their brain and they just took the tea, sorry, they took the milk, which is bad, right? Uh, and just continued, right? You end up with a tea that you can't drink, right? In the exact same, and that is how a computer will behave, right? If you don't check for the preconditions for your program to work and you sort of continue through, right? There are two possible ways, there are two possible things which could happen, right? One, your program will still error out, right? Because ultimately, it's not going to be able to continue doing what it's supposed to do because something is wrong somewhere. Um, but when it errors out, it will be far removed from where the problem is, right? Imagine if you have 100 steps in your program that you need to take care of, right? And you didn't check something at the step 5 properly, that, hey, I need data to be in this shape for me to continue, right? And you let it continue, right? So the step 6 will do something, 7, 8, it will just keep chugging through because program doesn't really understand what you're really trying to solve from the business perspective, right? And suddenly it stops 30, the data will get in such a bad shape, right, that program will finally crash, right? So that's one of the good outcomes in one way, that, okay, program still crashed, right? But what is going to happen is when you look at what happened and you try to investigate the issue, it will be very difficult for you to figure out what went wrong, right? Because step 30, when it fails, you're like, oh, how could this even happen, right? Because you need to be able to visualize in your mind at like what is the data flow at every step, and in your mind it will be very hard to put together how data can even come to this step, and then you will have to trace it back all the past step, like where it went wrong. Does that make sense, right? And that will mean that you will be troubleshooting that issue for couple of hours or even maybe more, versus, hey, if I just check at step 5 that I'm going to crash my program right away, you will immediately know what went wrong and you will be able to resolve that in, say, 5 minutes versus 2 hours. Okay, so the way I look at resilient system is not just in terms of, hey, that it doesn't crash, right? It is okay to crash. It's just that when it crashes, the system will tell you exactly why it crashed. And that makes it very, very easy, right? Because no one is expecting us to develop 100% foolproof software, right? It's not really an expectation in line of business application that, hey, it should never crash and it should handle all the possible scenarios that could happen automatically, right? We are not writing, say, software for NASA and sending the man to the moon that once the rocket is off, well, it better freaking figure out what to do in all the situations, right? And so that is what I mainly mean by resilient system, right? I want to make sure that it's not that the system doesn't crash, it's just the system tells you what is wrong for you to recover from it as fast as possible, right? And when you are developing system, your first instinct should be to write programs that crashes sooner and let it fail. Okay. And then business will say, you know what? No, 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 it should not fail the whole thing. You should handle it. Then you design the system to say, hey, you know what? If I encounter this, I'm going to put that aside, and then I'm going to do whatever I can do with the rest of the problem set or the data set. Does that make sense? Right? And going back to the two scenarios I was telling you about, other thing which would be extremely worse is program still runs all the way, but it produces garbage. And then someone comes in and says, hey, this doesn't make sense. And then you would have no idea where to even start, because system just ran through the entire 100 steps. Right? So think about all the processes that you're writing from that perspective. Like, hey, how do I ensure that when it runs, I know as a developer that it produced something meaningful for me. Does that make sense? Right? So now this is sort of a high level, and it is a little bit harder for me to give you a real world example, but I know you guys have been programming, so that at least you can visualize what I'm trying to get to here. Right? Okay. Now, one question that I wanted everyone to ask last week was around, let me share my screen, is actually, let me stop it for 1 second, right? One thing I wanted to actually ask everyone is like, hey, if I'm suggesting that you keep throwing exception, right? You should know like what to do about that though at the end, right? Like, how do you handle it eventually? So does anyone have any thoughts on as to how to handle it eventually though?
As in terms of like the waterfall of handling, like from the most specific to the most generic?
No, that's, so what I said, right? I said keep throwing exception. In your code, your job is to throw exception everywhere. Wherever you see something is not right, you should throw exception, right? Now, if I'm suggesting that, right, somewhere, some handler has to handle it and somehow do something meaningful with it. So any thought as to where that will be and how to think about that?
Yeah, so this is Mark. I joined a little late, so I didn't want to announce my presence, but one of the things that I'm currently doing at work is I'm writing a REST service that parses some files on a network share and returns that as a formatted JSON for users. So essentially, I have these classes that are responsible for parsing the specific files. And inside that that code is where I throw all the exceptions, like, you know, incorrect number of delimiters, or cannot, you know, parse to a specific date, you know, types, things like that. So that raises the exception, and then inside the actual request handler part of the application, I have essentially one function which calls a try catch block for the different types of exceptions. And so the exceptions raised are like specific to the actual application. So if, you know, a file has wrong delimiters, it sends that kind of error message, and that gets handled in the request such that the JSON returned to the user provides the right level of abstraction. And so that's the way that it's been designed. I think you'll probably review it this week. I don't think we got around to it last week, but but that's the logic that I've employed. So basically, the individual code throws the specific error messages because they have specific responsibility to just parse specific files, and then in the actual handler is where I handle those exceptions to provide the correct output for the user.
Perfect. So that's a good point. And let me try to articulate in a more general sense what I'm trying to refer to. Okay.
Yeah, good luck next week, Mark. JD's already identified like 10 issues with that approach. So
Yeah. Well, that's why I was very specific to this example. So before tomorrow, I can go rewrite it.
Funny. All right. So, okay. This actually, let me take you in a step back, right? Every line of code that you run, every application, right, has to have what we call an entry point, right? Every application has an entry point. And during that entry point, it will do some task, right? And produce something meaningful, right? And this thing is easiest to visualize, right? In, let's say, a command line program. Okay. So, which is basically what we are writing here, right? So let's say this was a command line program and you have some arguments, right? Say arguments equal to load file, right? And then you will have like, hey, if arguments equal to load file, run load file. If arguments equal to validate file, you will have validate file, right? If arguments equal to whatever, right? And then you will have something called, hey, I have a load file method to do some file loading, and I will have a validate file method to validate it, right? So what I like to say this is, these are your components which are sort of doing something meaningful. Okay. And the job of any of the components that you write should be to throw exception as much whenever there is an issue. Right? They should not think about, hey, what to do after that. Because that's not their role to worry about that. Okay? And the top level program where you are assembling the components, that component will decide as to when it runs into the exception, what to do about it, right? Should I crash the process and stop the execution? Should I, let's say, and in the case of a command line program, right, it's pretty much straightforward that, hey, I'm gonna just crash the process and write down the exception. And this is where it becomes tricky when you're talking about, let's say, a web service that you might be writing, right? Windows UI program you might be writing, right? And in that case, let's say if I talk about, say, REST API, right? So there, one thing to realize is, unlike, say, a console program, the entry point is when someone hits a particular URL and asks you to do something. Right? So let's say user hits, let's say he hits dev/load file, and then you have only that particular line of execution going on at that point. Right? And rest of the other endpoints which are hitting, they are not really related to the work that you are doing. So here, in a lot of the other other sort of programs that you write, so let's say you are talking about a Windows service, or you are talking about a Windows like a WPF program, right? They will provide some, each and every one of them will provide some notion of a global exception handler, right? And that is what you sort of use to figure out whether you want to crash the whole process, or do you want to just somehow log it or notify the user and sort of let the program continue running. Does that make sense? Right? So imagine if you will, or at least the way I try to structure my program is you will write variety of components. Right? And these components, which take some input and does something meaningful with it, right? They should be throwing exception. And then the job of handling what to do if something goes wrong should be left up to that code, which is assembling them together to do something meaningful. Does that make sense? Can someone say something? Because I can't see anyone and I'm confused as to if what I'm saying is making sense
Yes,
or not.
yeah, it makes sense.
Right? So each and every component keep throwing exception. No matter what application model you're programming in, it will have some notion of global exception handler or top level handler. So your final catch where you are handling the exception should be few and far in between, and everywhere else you are just throwing exception. Okay, and then as and when you learn from the users that, hey, you can't just crash the application, that is the time you update your component to sort of handle that situation a little bit better, right? Because a lot of time, and the reason I'm saying all this, and I'm gonna now give you a specific example, right? A lot of time you would see people's idea of exception handling is this: try file equal to say file dot read all lines. Whatever. Why am I not able to type? Sorry. Read all lines. A lot of time, I just see code like this. Right? And this is the worst possible thing you can do. This is not exception handling. And I know intuitively it does look, oh, there was an exception, I did something with it, but actually you didn't really do anything with it. You just logged it, and now that information is actually no more actionable by the code, which is instrumenting everything, right? So never ever write code which does this, right? This will leave you very difficult thing for you to figure out as to what happened in the system, right? Generally, whenever you do a catch exception for whatever reason, you should just add some context saying error happened trying to load file, right? And wrap that inner exception in there, right? And let a component higher level escalate, and then let it handle what to do about that error, right? And I know it may not sound very intuitive, like who's gonna handle it, who's gonna handle it, but if you adopt this, you will learn to find a top level handler where you can actually do something meaningful with it, right? So this is the first thing. Do not just catch exception and don't do anything with it, right? If you catch the exception, either you should just, if you want to, do some logging and throw it as it is, or you can add some context to it and then throw the exception. Does that make sense? Right? Now, other thing that I see a lot, and this is something was a long time puzzle for me. So if you look at C# coding guidelines, and in terms of the static code analysis checker, at least, they will have a guideline like validate parameters for all arguments of public methods, Okay. Do you, in the people who are in the call, how many people will always do this, that validate parameters for all arguments of public methods?
I think for me, it depends on the function. Funny, I actually just gave a talk on this with like Fibonacci sequence. So the general, if you write the Fibonacci sequence the way it's customly designed, you can pass a negative number to the function, and it'll return back the same negative number. But is that necessarily correct? Because a lot of mathematicians define the sequence as starting from the index 0.
So I'm not particularly talking about that example. I'm talking about literally, let's take a simple example of load file. You get the file path, and you must have writing a lot of different methods.
Right.
Are you absolutely without fail checking for nulls or bounds of the parameters? Always, without exception.
It depends on what the function is, I guess, is what I was trying to get at. Because with file reading, I think a lot of the exception handling will be thrown by the function itself. Like cannot find file or file does not exist, so I don't necessarily need to check that.
Right.
But I think with something where it's like, okay, here's a mathematical function and it's only valid between a certain region of input values, then that's where I would essentially a check or assert the values are within that range.
Perfect, right? So you are doing the one part saying, hey, for a certain mathematical function, I need to make sure the input is in bound, and you throw the exception. But I will posit and argue like, hey, you should do it for every single parameter, right? And I'll tell you why. Do you know what is the harder, can you name me the hardest exception to debug? At least in the C# world, if you run into it.
Exception?
Reference not set.
Huh?
The object reference not set to an instance of a type.
Yes.
That's the worst.
Exception, right? And I'm sure you all have run into that you get null reference exception, and it's like, and you're looking at some line of code where it has a bunch of things and you have no idea which part of the expression, like what component is actually null, right? And yes, a program will eventually crash if you don't validate the parameters, right? The difference is what error you get and what point you stop is completely different when you validate versus when you don't validate, right? So for example, if I'm talking about file dot, let me actually share this one here, right? Let's say if file path is null, right? And I'm passing that guy here, right? Now, this guy will throw null reference exception, right? And that will be less readable than, let's say you wrote is null or empty file path. Now you will get an exception saying, hey, file path parameter was null. Right? So that is why, so I configured the static code checker. Back in the day, it used to be called fxconf. And I always wondered about this myself. Like it will flag every single line of code where you are not validating the parameter at all. And the reason behind that is, as I was telling you, that milk example, right? By writing this, you just get a better error at a better step in the program versus you letting some other code throw the error, right? So you can even do the next thing here. If not file exist, file path, right? You throw one more exception here. Right? So you know by the time code comes here, it's not gonna throw like a hard to debug exception for you, right? And imagine if every single method that you write validates data like that beforehand. You're more success of having failure at the earliest possible point in the progress. Does that make sense? Right? So that is what you need to think about. Hey, how do I validate all the parameters for every single public method, right? Think of your program as it takes certain input, produces output, right? Overall at the program level, right? But your program could be made of components, right? And each component is all the same way. It takes some input and produces some output, right? And your job is to ensure that you only work on valid inputs and you produce a valid output. And when each and every component that you write works on the same principle, that is when you will have a good system which you can easily troubleshoot when something goes wrong. Right? So this is sort of a high level, and I'm guessing probably harder to visualize in the context of what you are day-to-day writing. But try to, at least going forward when you program, try to think about that. Right? Is the component I'm writing, whether it's an entire class or a 10-line method, am I validating the inputs that I care about, and am I making sure I'm producing the right output? And the more you do that, the more you will be able to assemble a better system, right? And then next thing, and how this ties into building resilient system, is how you do logging. Okay, so as everyone knows, you have 5 levels of logging, right? Trace, debug, info, warn, error. Right? I think error and warn is sort of self-explanatory, right? Everyone intuitively understands what's going on with those two. Can someone articulate to me these 3 levels, and when would you choose each level? Trace, debug, info. How do you choose when you write the program, whether to do log.info, log.debug, or log.trace?
I guess, yeah, I'm like spitballing. I'm just going to throw it out there. I don't know. Between debug and info, at least, like info is something you probably will enable in prod if you want to capture information that you want to, I don't know, look at later for whatever reason. Debug is primarily something you'll be running locally when you're building it out. I don't know if that's an option. You wouldn't necessarily keep it enabled outside of your local environment. Obviously, there's a lot of metadata that gets generated with it too, so you may not necessarily want to clutter that up either. That's between debug and info, I think, and I have no idea what trace is.
Okay. Like, but when you're writing a line of code, how do you make a decision whether you want to do debug or you want to do info between the two, right? Because you're sort of saying one thing that, hey, you know, locally when I'm doing, I'll use debug, but in the code, you have to make a choice, right? When you use whatever logging system you're using and you put log dot something,
right?
You have a choice, right? And I think warn and error are sort of simple enough for everyone to understand, right? You know when to use.
Right.
But between the 3 of them, how do you make that choice? Avi, Mark, I was hoping you would definitely answer, because I know you guys have been going through that challenge. You guys are telling me you want to clean up the logs. So what are your thoughts as to how do you choose?
My mentality is that, you know, if you care about knowing this information all the time, it's logging.info. If you care about this information only when something's wrong, then it's logging.debug.
Okay, that's a fair enough assessment. Ritesh, you were saying something?
So I have seen this example, and maybe I practice it at times that at the start of a function, let's say, like something that tells me, okay, the code has reached this point, and the end of a function, okay, this task is done. So the superficial task, I'll keep it as info, and so it's like inter functions, I'll keep it as info. Whereas if we are intra functions, let's say file is found at this location or something like that, I'll keep that as debug. So that if anything goes wrong, using info, I can at least trace down, okay, this is the function that went wrong.
Okay, and what about trace?
I haven't used trace.
Todd, have you made a choice, or you just go with info and just roll?
Yeah, it's all info all the time for me. I never knew trace even existed.
Okay, so so it took me also a long time to figure out the purpose of that, right? So each and every logging system that you might be using will always give you, okay, so the purpose of logging, right, and logging systems which are generally available, let's say Log4j, Nlog, or any of the system that you're using, they will separate out the log capture from writing code. So what I mean is, you can, let's say, do log.info, log.error, log.warn, right? But how that are manifested in a running system is separated out by means of configuration, right? So for example, you put log.error, and then you can configure, let's say log4j, right? You have a log4j.config where you can say, hey, for any which is error, send me an email, right? Or send it to Slack, or send it to Symfony, whatever you want to use. So that's the first thing to realize, that all the logging system that you will run into, they will separate out what to do about the logs as part of the configuration. So when you are writing the logging statements in your code, you don't have to think about what you're going to do with it. Makes sense, right? So I'm sure whatever system you're using, it would have configured that when error happens, send me an email, right? And the difference between info and debug is, whatever statements you put in info are when you want to check the status of the system and see what is going on at a high level, that where the system is in the progress. Okay? And debug is when you actually want to debug the system when something goes wrong, right? So you will have a lot more debug statements in your program than info statement. And through logging system, you can say, hey, you know what? Write down this in the log file, only the info statement. So that's what actually we already do for my projects. Is info statements are logged in a separate file for me to view, or in a separate system. And then when I want to know what is the running state of the system, I can just look at it and I'm like, okay, things are fine. This is what it is doing. But when something goes wrong, right, then I have another log file where I will see a lot more detail in terms of, hey, this is what the program is doing. Like, this is what it ran into, or file not found, or it only found this many items, and then I can debug my program. Another beauty of the logging system is such that you can say, don't do anything with the debug logs. Don't write them anywhere, don't do anything, right? But when you run into a problem and you want to troubleshoot what's going on, at that time you can tell the system, hey, start doing the debug logging so that you can debug the program, right? So the way to choose your logging level is, info is for you to just know about high level what's happening with the system, and it should be very to the point, and it should not have as much detail. Debug is to troubleshoot the program. And people use trace when they literally want to trace the program execution. And that will be the most granular level logging. So if you look at, let's say, when people are writing, say, when Windows itself is written, right? They will, in trace, you will say, hey, I got this parameter. So you will, at the beginning of the parameter, you say logger.trace parameter this, and you will say entered program, exited program. Every single thing that program is doing will be captured exactly as it is. And it will produce tons and tons of line items, right? And the goal is when you run into a very tricky problem in production, that time you will say, hey, I don't know if you ever run into, but they'll say, hey, enable the trace logging so that I can trace the execution of the program through every single method, function, input and output to figure out where something went wrong. So for our purposes, for LOB work that we do, you should just use debug onwards, right? Debug info, warn and error. We never really need to use trace, but trace is for some of those problems which are like where you have to do remote troubleshooting of a program and it's extremely hairy. You might just want to see a lot of details to even figure out what's going on.
So JD, for trace then, do you need to sort of litter these trace logging statements like all over the place throughout your code manually then?
So that's one way, right? That you put logger.trace statement everywhere. But now there is also something called aspect-oriented programming where you can have libraries, right? Which will put all the trace statements for you automatically.
It'll add them to the code that you see, or it'll sneakily jam them into the compiled code and you never see it.
So I'll talk about, so back in the day, what you had to do is literally write your trace statement in every method yourself, no choice, right? But in a language like C#, where you can, it generates the IL, after your code is compiled, someone can stick in the IL after the fact. Okay, so you don't really get to see it, and that's actually, that's a good question. There is this, let me share with you. So there is this aspect-oriented package called PostSharp, right? And what it does is you can just say, hey, log it, and then, so actually let me see, right? Imagine it would be, when you're troubleshooting the system, right? Sometimes don't you think it would have been super helpful if you had the values of the parameters and the values that you return and all that just sort of captured, right? But, and you know, it is very straightforward for you to do, but you know, it's just so tedious that you're not going to do it, right? But let's say these guys, right? They can, what they call IL weaving, they will write all those logging statements for you on your behalf without you changing it, you having to write it, right? And then you control from the logging side, how much information do you want to see, right? So I can say for a given assembly, right? Every single public method, log everything about it. And then it will capture parameters, return values, execution time for each and every function, source code file name and the number. And that will be very useful in terms of, hey, I want to troubleshoot what went wrong with the system. Right? And why am I actually I talked about logging as well is building a good system and being able to troubleshoot any issue with the system. It is highly dependent on the quality of your logging, right? So other thing you would see, like when people would just do logger.error and E and they will move on, right? And then you're like, you have all these logs and you can't make any sense of what's going on. Some people will log and then they will again throw the exception, right? And then some higher level will again log it. And then one higher level will again log it. And now you will see the same error multiple times, right? Raise your hand if you have run into that issue. That you just see the same error multiple times and you're like, what the heck? Ritesh is raising both the hands, right? That is because you are not thinking of you as in, I'm not talking like people are not thinking about, hey, how does logging interact with your structured exception handling and how to actually manage it properly, right? You should, unless you are swallowing the exception and stopping the execution, you should absolutely not log the exception. Right? Because this guy will propagate upwards and someone will definitely log it again. Right? And when you really want to say, hey, I want to stop this exception going over, this has to be at the very, very top level. It cannot be in your individual components that you have this catch exception E and you are just logging it. Right? And you're very, very free to say, hey, you know what, I want to wrap it, right? And throw it. Now imagine, if you will, that there is an entry point to the, there is a main method, right? And it calls a component A. It calls a component B. That calls a component C, right? You let this guy log the exception. This guy is very free to raise exception, rewrap and raise, right? And let's say you rewrap and raise, right? But when you log it here, you will see like, oh, component A called component B called component C, and this is the chain of events which happened, and this is where something went wrong. But you just get one meaningful log entry with the proper stack trace and everything for you to make sense of what's going on.
Hey, can you quickly just flesh out this concept of wrapping? That one's new to me. If this is basic and everyone else knows this, then you can pass it on, but I'm not sure what you mean by wrap.
Sure. I think, let's do that quickly. So let's say you call method A. That calls method B. That's called method C, okay? So method C will say throw new invalid operation, like something went wrong, right? Now, method B has some logic, right? And then it is calling method C, right? But you wanted to sort of say, hey, I want to add some context around something went wrong. So I can do catch any and all exception, and I'll say, hey, an error happened, error message is e.message, and you will throw a new exception, and you will pass the exception that you caught as part of it. And that is what I mean by wrapping the exception. So this is like wrap and throw, right? And then let's try the same thing. And here an error happened in method A. Right. So now when I call the what happened? It didn't call the load file method. So now when you just log that top level exception, right, you would see an error happen in method A, in B, and C. So you can see exactly what was happening in terms of the stack trace. Right? Because an exception class has this property called inner exception, which is what you are carrying over when you do when you catch an exception and wrap it inside another and keep the original as part of the constructor's parameter. Does that make sense?
Yeah, thanks.
Yeah. So the idea is what you would have seen, right? Generally, the code that I have run into is more like every single guy will try to log it, and when you look at the log, and it's like, how do I get to the bottom of the problem, right? And that is how you avoid it. You do not try to log the exception. You always say, I'm going to wrap and throw, right? You catching a top level try catch and finally stopping the execution of the program should be very few and far in between. It should not be common, right? So Pawan, how is the log quality of your systems?
There are some good things that, I guess, like I said, right, stuff I picked up from you that are important. There are guys in the team who follow diligently. Things like the ones you mentioned, when you pass in a file path, check for like string is null or empty or white space right away. So you're not even getting to like letting the rest of the program pick it up because it's meaningless. So that part's being done. The part that's actually very poorly being done is not capturing it at just the outer level, but like logging it. And it's gotten so bad that out of habit, when something fails once, people are like, yeah, it's fine, it's probably not that important. Something fails 3 or 4 times, now you know it is really important because you care to log about it 4 times. So it's like people have adjusted themselves based on how the logging is done, as opposed to fixing how the logging should be done. So even the one error that goes out should say that you should look into it. So it's, yeah. So clearly there are things that can be done, but how bad practices can change people versus people trying to change bad practices. So.
Right. And the part of building the resolution system is what kind of logging you get out of it when something goes wrong. And that is what you need to focus on, right? And if you really master the art of throwing the exceptions and rewrapping and throwing them properly, you will just end up with a much better quality system overall. Just this is strictly from the coding perspective. There are other techniques in terms of how to handle error situation. I want to talk about it next week, but for this session at least, that is what I had in mind in terms of what I want to cover. Ritesh, any thoughts in terms of the code that you have seen and the issues you have run into?
I've absolutely seen worst quality code. So yeah, logging and exception landing are important, extremely important.
Right. So there, I think I want to sort of talk next week, if possible. What I want to talk about is, hey, I have this code and it crafts in a particular way. How do you handle it better? Because I'm finding that now I'm talking so high level that, yeah, when we talk about it, it sort of makes sense, right? But to really nail down the concept, I think it's important that we take some concrete example of a code or system that is not doing what you are looking to do, and how to get it to behave in a much better fashion. So would one of you guys will have some sample where you're like, this is problematic, but I don't exactly know how to get to a better state, or is there even a better stage possible?
I can check if I don't promise, but I'll see if I can take some snippets off of our code base. I just want to make sure that I don't violate any non-compete and other bullshit. So just
So
want to
we will not make those videos public or anything, so you don't have to worry about it, right? I'm going to even trim out this discussion.
Yeah, no, it's like my sessions. I'll take screenshots. They don't even let us like copy and paste from remote sessions into local. So they're pretty. I mean, it's a public firm, so they kind of have to, I guess.
Yeah.
But I don't commit. So I'll see if I can pull some examples out to talk about how it's being done in a shitty way, and I'm pretty sure it can be improved. But
and you can just reconstruct the scenario, right? You don't have to have the exact code. You can say, hey, this is what is happening. This is the challenge I'm running into in terms of troubleshooting a system, and then we can take that example and try to break it down and say, hey, if we do it this way, then you would be able to handle it in a much better fashion.
Okay. Let me see what I can extract. I'll ask one of my guys to pull some snippets out, and I'll see how I can share it with this crew.
Right. And Mark, with our market data, the problem is you log too much, and then you don't know where to even look when something goes wrong, right? So it's such
It's that, and the funny side of thing, or the other side of things too, which is like the real problem is we have like these actual exceptions we write in the code, but we swallow them in other places. So all you end up in the logs is like the useless information. And it sounds like a joke until you actually like look at it. I mean, it's not intentional. It's just, when some of this was written the first time, it was like some people's first go around at it. And so yeah, that'll be changing. But yeah, I mean, that's what we do is we log everything. Like time is 8 o'clock, job is running at 8 o'clock. Okay, cool. Like.
Right. So I think one thing I want to do is I want to probably, Todd, maybe you and I will talk, but I think I'm finding that what I want to talk about building resilient system, right? It's very hard without being able to actually look at some real life example and real life code.
Yeah.
Right. So I will try to do that. And Todd, let's talk about, if we can find some examples ourselves, maybe find a demo project that we do together, and just try to build a mini system over the course of 4 or 5 weeks, and then we can meaningfully see all the relevant techniques at play.
Yeah, sure. Okay. Let me know. Let's chat.
Yeah. Hey, Alan, we actually shifted the time to 11 o'clock.
Oh, great.
Yes, you are right on time, but I had sent out an updated invite and updated time because everyone preferred sort of doing it earlier than 12.
All right. Well, I've been on a 3-week drive around the country, so I've not been paying attention to my email or getting anything. So got a lot of catching up to do.
I don't know if it's you shaved, but you look much younger than you did the last time you were on the call. So
yeah, I had to.